Good day, students. I'm Mr. Kobe, your teacher for basic mathematics. I hope at the end of the teaching, you will be prepared for your forthcoming examination. Our topic for today is word problems. Under word problems, we have other subtopics such as sum and differences, product, solving problems involving product, sum and differences. So starting with the first topic, sum and differences. The sum of two numbers is the result we obtain when we add two or more numbers together. For example, when we talk about the sum of 2, 3, and 5, it simply means adding 2 to 3 to 5, the answer we get is 10. So 10 is the sum of 2, 3, and 5. When we talk about the difference, we are talking about the difference between two numbers. That is the answer we get when one number is separated from the other. Take for instance, if I say 3, the difference between 3 and 1, my answer is 2. That gives me a positive difference. Or if I say 1 minus 3, my answer is minus 2. That gives me a negative difference. So when we talk about positive difference, we are talking about when we subtract a smaller number from a larger number. That gives us a positive difference. But when we subtract a smaller number from a larger number, when we subtract a larger number from a smaller number, that gives us what? A negative difference. So with that, we go to the first example, which says, find the sum of the following: 89 and 98, B, 3.5, 2.5, and minus 1 whole number, 3 over 4. So looking at solution A, sum of 89 and 98. So what we do here, we just simply arrange these two numbers in their order of what? Place value. So if we add 8 to 9, we have 17. We write down 7 and carry 1. So if we add that 1 to 8, we have 9. 9 plus 9 gives us 18. So the sum of 89 and 98 gives us what? 187. So the B part of the equation, which says sum of 3 whole number 1 over 2 and 2 whole number 1 over 2 and minus 1 whole number 3 over 4. This will boil down to 3 whole number 1 over 2 plus 2 whole number 1 over 2 minus 1 whole number 3 over 4. But we don't do that. What we do is to express these numbers as single fractions. So the 3 whole number 1 over 2 gives us 7 over 2. And the 2 whole number 1 over 2 gives us 5 over 2. And that of 1 whole number 3 over 4 gives us 7 over 4. So the next thing we are going to look for is the LCM between the LCM of 2 and 4. And the LCM of 2 and 4 is 4. So 2 into 4 gives us 2. So 2 times 7 gives us 14. And 2 times 5 gives us 10. And 4 into 4 gives us 1. And 1 times 7 gives us 7. So when we add 10 to 14, we have 24. So the solution will now boil down to 24 minus 7 over 4. And that gives us 17 over 4. And when we divide 17 by 4, we have 4 whole number 1 over 4. Then the second example is this. It says the sum of 4 consecutive numbers, the first sum of 4 consecutive odd numbers is 112. What are the numbers? When we talk about consecutive numbers, we have three types. One is what we call the consecutive numbers. The second is consecutive even numbers, and the third is consecutive odd numbers. So let us look at consecutive numbers. What do we mean by that? If we look at our numbers, so if we count on the natural numbers, say 1, 2, 3, 4. This is a typical example of consecutive numbers. So we find out that the difference between the first number and the second number, the second and the third and the fourth is just 1. We will have a constant factor, which is 1. Then that of odd numbers, we have 1, 3, 5, 7, and 9. We find out that the difference between these numbers is 2. So if you have a question like this, the sum of 4 consecutive odd numbers is 112, then what are the numbers? So what we do is, because we have an unknown value, we start by saying let the first odd number be x. So the second odd number will be x plus 2, the third x plus 4, the next will be x plus 6. So if you add all this, that's x plus 2 plus x plus 4 plus x plus 6, will give us 112. So if we put all this together, we have that 4x plus 12 will give us 112. So solving, we have that 4x is equal to 112 minus 12, and that will give us 4x equal to 100. So that x becomes 25. Meaning that the first odd number is 25. So the second odd number will be 25 plus 2, which is 27. The third will be 27 plus 2, which is 29. And the last odd number there will be 29 plus 2, that is 31. So that leads us to the third question, or the third example, which is find the negative difference between minus 12 and minus 25. We are talking about the negative difference, like I told you earlier. That negative difference simply means when we subtract the larger number from the smaller number. So we are going to identify the smaller number between minus 12 and minus 25. So with the aid of our number line, we find out that minus 12 comes before minus 25. So the smaller number here now is minus 25. So our negative difference simply means that our negative difference is simply minus 25 minus minus 12. So minus 25 minus minus 12 will boil down to minus 25 plus 12. Why is it plus 12? The minus times minus under rules of sign is positive. So that is why the minus 25 minus minus 12 will give us minus 25 plus 12. So what should be our final answer? How do we take care of minus 25 plus 12? Looking at the numerical value of the negative value, we discover that the numerical value of the negative value is 25 and that of the positive value is 12. Which one is greater? The numerical value of the negative value. So meaning that our answer will be a negative value. So in that case, we put down the minus and simply say 25 minus 12, and that will give us 13. So our final answer is minus 13. So our next topic, like I told you, is product. What is product? When we multiply, when we have two or more numbers, and we multiply these two, all these numbers together, the answer we get is known as the product of these numbers. So that will lead us to example 4. The example 4 says, find the product of the following. A, 8 and 6.5. B, minus 7 and minus 12. So how do we take care of solution? A, product is simply 8 times 6.5. And when we multiply 8 by 5, we have 40. So put down 0, then because we have a dot, we have a decimal point there, we put the decimal point, and we multiply and carry 4. So 8 times 6 is what? 48 plus 4, that will give us, 8 times 6 will give us 48 plus 4, that will give us 52. So the product of 8 and 6.5 is simply 52.0. So looking at the product, there is a B part of the question, which is minus 7 and minus 12. So the product is simply minus 7 times minus 12. Minus times minus, like I earlier told you, is positive, which is plus. So this will boil down to 7 times 12. And 7 times 12 is 84. Why? Because 7 times 2 is 14. You write down 4, carry 1. Then 7 times 1 is 7 plus 1. That boils down to 8. So our final answer there is 84. So we look at the fifth example there, which says the product of two numbers is 180. If one of the numbers is minus 15, find the other number. Here we are talking about one unknown value and one known value, whose product will give rise to 180. So what we do, first of all, is to assume that the unknown number is x. So the product of the unknown number, which is x, and the known number, which is minus 15, will give us x times minus 15, which is minus 15x. This minus 15x will boil down to 180. So x now will be 180 divided by minus 15. And when we do that, mathematics will have minus 12. So our last topic here is on this topic is solving combined products with sums and difference. And that leads us to example 6, which says add 12 to the positive difference between 45 and 30. Add 12 to the positive difference between 45 and 30. What do we mean by a positive difference? It simply means subtracting the smaller number from the larger number. So the larger number between 40 and 30 is 45. So the positive difference here is 45 minus 30, which will give us 15. So when we now add 12 to 15, that will give us, which is the sum of 12 and 15, that will give us 12 plus 15. Our final answer is 27. Example 7 says, subtract the product of 9 and 40 from 450. Product of 9 and 40 simply means 9 times 40. If you multiply 9 by 40, the answer will be 360. So the difference is simply 450 minus 360. And when we do that, we have 90. With that, I say thank you, class.
Good day, students. My name is Mr. Peter Nwanono. I'm here to revise with you on a topic called calculus. And here we are going to be looking at a subtopic under calculus, which is known as differentiation. Now, differentiation, what is differentiation? Differentiation is the differential coefficient we derive from a function. Differentiation is the differential coefficient we derive from a function. Let's say, for instance, we have y equals x squared. The differentiation there, which is the differential coefficient, is dy over dx equals 2x, which means you have differentiated the x squared to give you 2x. But very quickly, this is just a brief background on differentiation. We are going to be revising differentiation from first principle. Now, in looking at differentiation for first principle, we have if y equals s squared, the same y equals s squared. We have here, how do you solve the differential equation where you have y equals s squared? Using your first principle. In this case, there is what is called an addition of small increments. This addition of small increment on y and x is done in such a way that you add the y and the x. In this case, your the y and the x is written as delta x, delta y, and delta x. Now, when you add this delta y and delta x respectively on both sides, if the equation will transform from y equals x squared, it will now give you y plus the x equals x plus the x bracket square, which means you have gotten your y plus the x equals x plus the x, giving you what? X squared. So you see that you are now adding that small increment, the y to y and the x to x. In this case, in solving further, we say subtract y and x from both sides of the equation. So if you subtract y from the left hand side and subtract x squared from the right hand side, it will give you y plus the y minus y equals x plus the x all in bracket square minus x squared. Now in this case, you find out that on your right hand side we have a fractional value there which has what? A square at the point. How do you now expand it? We are going to introduce what is called binomial expansion in expanding that particular word function. So on my left hand side where we have y plus the y minus y, you see that your y will take care of the minus y. Then we're now left with what? Your dy equals, now when you expand your x plus the x all squared, it will give you x squared plus x 2x dx plus the x squared minus x squared, because we have said subtract y from the left hand side and x squared from the right hand side. So if you solve further, you see that your x squared now after the expansion will take care of the minus x squared on the other side. And when you look at that, that will now give us the y equals 2x the x. And at this point, plus the x squared. What do we now do at this point? We say divide both sides by the x. On my left hand side, we are going to have the y over the x. On my right hand side, we are going to have 2x the x over the x plus the x squared over the x. Now you see that on my right hand side, the 2x the x over the x will take care of the x, leaving us with 2x. Plus the second part of it, which is the x squared over the x, will leave us with us. When you take the x, take care of one the x from the x squared, we'll be left with the x. So we now have the y over the x equals 2x plus the x. At this point, we take a function which is called limiting function. We now limit the x to 0. When you limit the x to 0, on my right hand side, transform automatically to dy dx, which is called the differential coefficient, which is equals 2x, because the x on my right hand side will tend to 0. So that one will vanish. We will now left with what? 2x. So you now find out that using your differential coefficient of solving from first principle, we now have that dy over dx equals 2x, which is primarily a very simple way of saying y equals x squared. When you differentiate your y, you will get dy over dx equals 2x. Now let us consider another example, a case where y equals x cubed, that is to the power of 3. What happened? The same way, following the same method of your first principle, we now say again, add small increment of y and small increment of x on both sides, which means on my left hand side we are going to add the y, and on my right hand side we are going to add the x. At this point in time, you find out that on my left hand side we'll be having y plus the y equals x plus the x in bracket to the power of 3, because we are considering x equals 3. Since we are adding small increment to x, that will give us x plus the x to the power of what? 3 in bracket. So at this point again, what do we do? The same way we did when y equals x squared, we do the same thing. we subtract y on my left hand side and subtract x cubed on my right hand side. Now on my left hand side, we are going to have y plus dy minus y on my right hand side equals x plus the x power cube plus minus s cube, because we are saying subtract s cube on the right hand side. Now if you expand your x plus the x to the power of 3 using binomial expansion or Pascal triangle, it will give us s cubed plus 3x squared dx plus 3x the x squared plus the s cubed minus s cubed. Now you see that we have now gotten another what? Equation. At this point in time, what do? My y on my left hand side will take care of the y. We now have y minus y, we will be left with what? Dy equals s cubed plus 3x squared dx plus 3x the s squared minus plus the s cubed minus your s cubed. Now at this point, what do? You see that your s cube will take care of the s cube. And when the s cube take care of the s cube, we will now be left with, on my left hand side, dy equals, on my right hand side, we have 3x squared dx plus 3x dx squared plus the s cubed. Now again, we divide both sides of the equation by the x. So that on my left hand side we have dy over dx equals, my right hand side now we are going to have 3x squared dx over dx plus 3x dx squared over dx plus the s cube over the x. Now you see that the x in the first term, which is 3x squared dx, the dx there will take care of the dx. We are now left with what? 3x squared. Then the second part we have 3x dx squared over dx. The x will take care of one dx. We are left with what? 3x dx. And the last part of that expression is what? The s cube over the x. So when the x will take care of the s cube, we will left with what? The x squared. Now at this point in time, we now have on my left hand side dy over the x, and on my right hand side equals 3x squared plus 3x dx plus the x squared. Now again, introducing the limiting function, what do we have? We have limiting the x tends to 0. At this point, when you limit x tends to 0, like I said earlier on, your dy over the x automatically becomes dy dx. Now on my right hand side, we will have 3x squared plus 3x dx. We now what? The x there will limit to 0. Then your dx squared also will limit to 0. So at the end, we have dy over dx equals 3x squared. So that shows that we have differentiated your y equals s cubed to be what? Dy over dx equals 3s squared. So you see that it is just as simple as that. This is the process of following what? First principle in differentiating a differential function. Now, this process of differentiating to arrive at that differential coefficient is what is known as what? Differentiation. Now, the solution 3s squared is called a differential coefficient. That differential coefficient whereby you have dy over dx equals 3s squared is known as what? Differentiation. Now, we go to the rules of differentiation. What are the rules of differentiation? We have two basic general rules of differentiation. Then we still have other rules where we talk about the chain rule, the product rule, and the quotient rule. But meanwhile, let us take the general rule. In the general rule, we have the first general rule which says if y equals s power n, then dy over dx equals nx power n minus 1. Then there is also another case whereby we have a constant coefficient multiplying such function. That is, if y equals ax power n, then dy over dx equals a times n x power n minus n. So in this case, it means that for the first one is when you have any value for n. N could be 1, could be 2, could be 3, could be 4, as the case may be. What it does mean is that if y equals, let's take an example, if y equals x power 5, you see that n there now has been replaced with what? 5. It means that at this point, n equals 5. So if y equals x power 5, then dy over dx will simply be 5 times x raised to the power of 5 minus 1. And that will give us 5x raised to the power of 4. Simple as that. Then we take another example. If y equals 4x power 3, what would that give you? You see that this particular one is following the second general rule of ax power n. Now you see that in this case, we have if y equals 4x power 3, then dy over dx becomes 4 times 3 x to the power of 3 minus 1. So what is 4 times 3 now will give us 12. Then our answer becomes dy over dx equals 12x raised to the power of 2. These are just simple logic and simple knowledge. It's just very, and they emanated from what? From your normal indices. It means that for you to be able to solve a differential function, you need to have a primary knowledge of indices. So you see that indices is now playing out here again in differentiation. Now we take another example. If y equals 9x to the power of 4, then dy over dx equals 9 times 4 x to the power of 4 minus 1. At that case, you will now find out that your 9 times 4 will give you 36. Then x to the power of 4 minus 1 will leave you with 3. So your answer becomes dy over dx equals 36x to the power of 3. Again, we may look at another example where we have an expanded form, where we have y equals 4x power 3 plus 2x power 2 minus 3x plus 4. How do you solve this? You see that in this particular question, we have 4 terms on the right hand side, where we have the first term as 4x power 3, the second term as 2x power 2, the third term as minus 3x, and the fourth term as 4. Now note that anytime you differentiate a constant value that does not have any form of letters, it means your result will be 0. Anytime you differentiate a constant value, let's say you are differentiating 1000, your result is 0. If you differentiate 5, your result is 0, because there is no coefficient, there is no letter attached to that particular value, so it will give you 0. Now in this particular question where we have y equals 4x power 3 plus 2x minus 3x plus 4, we are going to find out that the first term, if you differentiate the first term, we are going to have 4 times 3x power 3 minus 1 plus 2 times 2x power 2 minus 1 minus 3 times 1x 1 power 1 minus 1. Then see that your 4 will become 0. At this point, our resultant solution becomes dy over dx equals 12x power 2 plus 4x minus 3, because where you have your 3 times 1, x raised to the power 1 minus 1, 1 minus 1 will give you 0. So when you have x power 0, remember in indices, the fourth law of indices says when x raised to the power 0, you have what? 1. So when you have x raised to the power 0, you have 1. So you have 3 times 1 will give you 3. That is why we are having 12x squared plus 4x minus 3 as our solution. That is our differential coefficient. Now let us see another case where we have y equals 1 over x. If you recall, in indices also, this is called what is known as inverse or reciprocal law. Now, in this particular inverse law, you find out that your 1 over x can be written as x raised to the power of minus 1. So we now have that the equation as y equals x raised to the power of minus 1. The same way, when you differentiate your y, you will have dy over dx. Then your right hand side, what are you going to have? We have minus 1 times minus 1 minus 1, following the general rule. Because the general rule states that if y equals x raised to the power of n, your resultant solution will be n times nx n minus 1. So our power now is minus 1. So we have minus 1x minus x raised to the power of minus 1 minus 1. So at this point, we now have that your dy over dx equals minus x minus 2. Minus x raised to the power of minus 2, because your power now is minus 2. Now, you will not leave your answer like that again. You have to return it back to the way the question is presented. Remember, our question is y equals 1 over x. So your answer becomes y equals minus 1 over x power 2, because you are still following that same law of indices, bringing your inverse value back to what? To a fraction. So in that case, you see that differentiation following the general principle is very, very easy. Now we go over to the chain rule. Now, how does the chain rule operate? So to find the derivative of a function such as y equals 2x minus 7 raised to the power of 5, here we find out that we have two functions. There are two functions here, because one, the first function is the function inside the bracket, and another function is the function carrying the power. Now, to solve this particular problem, the chain rule states that for you to be able to solve such a problem, your function inside the bracket must be represented by a particular letter. You can choose any letter of your choice. But in this particular case, for convenience sake, we use the letter t to represent that particular function. So we say let t represent your 2x minus 7. Now if we differentiate t with respect to x, we are going to have 2. Why? Because your minus 7 is a constant value. And whenever you differentiate a constant value, it gives you 0. So your 2x will just simply means 2 times 1, x raised to the power of 1 minus 1, which will give you 1 minus 1 is 0, x raised to the power of 0 is 1. So you have 2 times 1 to give you 2. So we find out that our dt over dx is 2. Then we now replace, since we have said let t equals 2x minus 7, we replace t in that particular question. Then we now have y equals t raised to the power of 5. Then again, you differentiate now, because the letter you are seeing there now is t. You are going to differentiate y with respect to t. When we differentiate y with respect to t, we have dy over dt equals, following the general rule again, here we have t raised to the power of 5. So we now have 5t raised to the power of 5 minus 1. And 5 minus 1 will give us 4. So dy over dt becomes 5t raised to the power of 4. Now you see that, but what we are requested to find is dy over ds, which is the differential coefficient. Now, how do you solve that? You will now say that your dy over ds equals dy over dt times dt over dx. When you do that, you see that the values you have gotten from dy over dt, which is your 5t raised to the power of 4, times the value you've gotten from your dt over dx, which is 2. You now multiply the two of them, and that will give us 10t raised to the power of 4. But remember that you have said let t equals 2x minus 7. So which means we have to replace the value of t back to its normal form, so that your dy over ds becomes 10 in bracket 2x minus 7 raised to the power of 4. So this is the way you can use chain rule to solve a differential function. Let's take another example. If y equals 3x plus 8 raised to the power of 6. How do you solve the same problem? We find out that the same way we have y equals 3x plus 8 raised to the power of 6, we now say again, let t represent 3x plus 8. When 3 plus t represents 3x plus 8, we are going to differentiate again t with respect to x. When you do that, we have dt over dx equals 3. Because at this point again, your plus 8 is a constant value. And whenever you differentiate a constant value, it gives you 0. So your dt over dx becomes what? 3. Now, we go back again to replace t with that function 3x plus 8. So we have y equals t to the power of 6. Now when we differentiate y with respect to t, we are going to have dy over dt equals 6t raised to the power of 5. That is, you have said t times 6 times t raised to the power of 6 minus 1. So your 6 minus 1 is giving you 5. That is why you have your dy over dt equals 6t raised to the power of 5. Now, replace the value of t, which is 3x plus 8. When you replace it now, you see we are going to have our dy over dx becomes dy over dt times dt over dx. So we now have your 6t power 5 times 3. Now, the coefficient value there, 3, we multiply 6 to give us 18. So we have dy over dx equals 18t raised to the power of 5. Now, t will be replaced by its original function, which is 3x plus 8. So we now have dy over dx equals 18 into 3x plus 8 raised to the power of 5. So that is the solution of that particular word, of that particular problem. So at this point now, you see that we have used chain rule in solving that particular differential equation. Then we move over to product rule. Now in the product rule, we simply have, if we have a function y equals uv, what it means that u is a function of s and v is a function of s. It means that you are multiplying two functions together. Now there is a general rule of product rule, which is dy over dx equals v du over dx plus u dv over dx. What it means that you have to differentiate the function of u with respect to s and the function of v with respect to s. So let's take a typical example. If, for instance, we are asked to differentiate y equals x power 5 into 2x plus 1 raised to the power of 3. You see that we are having two functions multiplying each other. The first function is x power 5, which is u, and the second function is 2x plus 1 power 3, which is v. So when we do that, if you differentiate your x power 5, you are going to have 5x power 4. And when you differentiate your 2x plus 1, we are going to have 6 into 2x plus 1 raised to the power of 2. So when you put this now into the original equation, which is dy over dx equals v du over dx plus u dv over dx, we are going to have 2x plus 1 raised to the power of 3, 5x power 4 plus x power 5, 6 in bracket 2x plus 1 raised to the power of 2. Now when you simplify out, we are going to have 40x power 7 plus 60x power 6 plus 30x power 5 plus 5x power 4 plus 24x power 7 plus 24x power 6 plus 6x power 5. Now when you simplify further, we will now have dy over dx equals 64x power 7 plus 84x power 6 plus 36x power 5 plus 5x power 4. At this point in time, I want to tell you that differentiation using product rule is very, very simple. All you just need to do is to apply the rules. When you apply the rules, know when to differentiate u with respect to s, know when to differentiate v with respect to s. And your ability to differentiate between u and v makes you to be able to solve such particular problem. I want to say that this particular revision class is not going to be sufficient to enable you pass exam, but it's just to aid you learn problems on how to solve differentiation in whenever you are revising. So please do well to read other materials that will assist you in solving differential equations so that you can prepare adequately for your examination. Thank you and God bless you.